Okay, this is the second part of sum and difference formulas. And we're going to go through a couple more examples. In the first one, we're going to combine skills from last chapter with skills from this chapter by graphing this big, long function here. Okay? It looks pretty daunting, to be sure. But we're going to try to make our lives easier by saying, what if I tried to factor something out? And I notice that I've got a 4 in front of both of these. So what I'm going to do is I'm going to factor out a 4 and write what I have left. And when I do this, I notice that what I have left is really actually one of the formulas that we've come up with, okay? And so this is going to be the formula for sine of a minus b, okay? This part right here, okay? And so what I'm going to do is now I can shrink this down. I've still got 4 times sine of 5x minus 3x. Okay? So because of the way this was formulated, it shrinks down to this. Well, that really equals 4 sine of 2x. And I know how to graph this, so I'm going to do amplitude and period, vertical translation, and phase shift. So, with an amplitude of 4, I know it's going to go between 4 and negative 4. 2 pi is going to be my period, so halfway is pi. This is going to be 3 pi over 2, and this one's going to be pi over 2. I'll even graph in a different color. Watch this. It's a sine graph, so it starts here, positive, maximum, minimum, 0. Connect the dots right like this. Okay? This is the key right here. Knowing that these two things are the same. Okay? Let's move on to the next example. The key to doing these sum and difference formulas problems is really picking out exactly what is easiest for us. Okay, so when we find the exact value of pi over 12, we need to know what makes up pi over 12. Well, if I think about this in a certain way, I can kind of come to grips with easy things. Okay, so if I look at pi over 3, pi over 4, pi over 2, I'm asking myself, what are these as twelfths? Because that's my denominator. And these are my easy fractions from my unit circle. They're going to base most of these things on the unit circle. And so if I look at this, pi over 3 is really 4 pi over 12. And this one is 3 pi over 12. And this one is 6 pi over 12. Right? And so if I look to two of these that are going to give me a difference of pi over 12, it's going to be 4 pi over 12 minus 3 pi over 12. Okay? And so really this is the sine of these two things, which equals the sine of pi over 3 minus pi over 4, right? Because I know that those are actually equal. And so when I expand this, this is going to be the sine of pi over 3 times the cosine of pi over 4 minus okay? I switched these around a little bit, but that's okay. Now, how do I do this? The sine of pi over 3 is square root of 3 over 2 times, now let's do a little bit of an investigation here. The square root of 2, or 1 over the square root of 2, is really equal to the square root of 2 over 2 because of this. 1 over the square root of 2 times square root of 2 over 2, square root of 2 over square root of 2, would be square root of 2 over 2. So these are actually equal. Okay? They are the same thing. So whether you see one of these written or the other, it doesn't really matter. Back down to my problem. Minus I'm going to multiply across. So I have the square root of 6 minus square root of 2 over 4. Because my common denominator here is 4 for each of these, so this is my answer. This is an exact value. Not that calculator stuff that's rounded, okay? This is an exact value. So that's an example of how to do one of those. In example 7, they're giving us specific parameters. And they've said the sine of A is 3/5 with A in quadrant 1. The cosine of B is negative 5 over 13 with B in quadrant 3. Find the sine of A plus B and the cosine of A plus B and the tangent of A plus B. Okay? So, how do we accomplish something like this? To accomplish something like this, we're really going to have to break it down into what it means. And so, if I want the sine of A plus B, let's just write out what this means. The sine of A plus B is going to be sine A times cosine of B plus cosine of A sine of B. Okay? The cosine of A plus B is going to be cosine of A sine of B minus sine of A, oops, sorry, my mistake, I got carried away. This should be cosine of A cosine of B times sine of A sine of B. Now this tangent business. What is with this tangent business? When they ask us to do tangent, they're asking us to find a certain value here. Okay? And so what I'm going to give you is I'm going to give you the formula for this. And the tangent of A plus B is going to be tangent of A plus the tangent of B over 1 minus tangent of A times tangent of B. Okay? So these are what we need. Now, in order to do this, we're going to have to find certain values given to us. Well, we don't have the cosine of A. We have the cosine of B, we have the sine of A. So the cosine of A from our identities is equal to the square root of 1 minus sine squared of A. Well, that's going to be square root of 1 minus 3/5 squared, which is going to be 25 over 25 minus 9 over 25, which is going to give us the square root of 16 over 25, which is 4/5. Now, because it's in quadrant 1, it's going to be positive. Okay, so that's the cosine of A. Let's find the sine of B. The sine of B is equal to the square root of 1 minus a negative 5 over 13 squared, 169 over 169. I'm making my common denominator the same denominator as my fraction here. So this is going to be minus 25 over 169, which is 144, over 169, which is equal to 12 over 13. And because it's in quadrant 3, I know that it's going to be negative, because sine and cosine are both negative in quadrant 3. And so what I have is sine A is 3/5, sine B is negative 12 over 13. The cosine of A is 4/5. The cosine of B is negative 5 over 13. I have everything I need to do sine of a plus b and cosine of a plus b. So let me start in a different color. So sine of a plus b wrote them too close there. The sine of a plus b is going to be equal to sine a cosine b plus cosine a sine b, which is equal to 3/5 times negative 5 over 13 plus cosine of a 4/5 times sine of b negative 12 over 13. Doing a little bit of multiplication, I get negative 15 over, now because these are multiplied, I'm going to multiply my denominators. So I'm going to get 65 plus 4 times 12 is going to be negative 48 over 65, which is going to give me negative 63 over 65. That is the sine of a plus b. Now, cosine of a plus b is equal to cosine of a times the cosine of b minus sine of a sine of b. So that's going to give me 4/5 times negative 5 over 13 minus sine of a, which is 3/5, times sine of b, which is negative 12 over 13, which is going to give me negative 20 over 65 minus negative 36 over 65. And that is going to give me negative 20 minus a negative 36. This is going to end up giving me 16 over 65. Now, tangent. When I do the tangent of these two things, I am out of room, so I'm going to scroll down. The tangent is going to be the tangent of A, tangent of B. Well, we need to figure out where we actually get these from. Okay? And so, if we are going to find these things, we're going to need some help. Okay? And so, I have one of the formulas here. Tangent of A plus B is going to be tangent A plus tangent B over 1 minus tangent of A times tangent of B, and tangent of A minus B is going to be tangent of A minus tangent of B over 1 plus tangent of A, tangent of B. Luckily for us, I have it written down here again, okay? And so this is going to be the last example. And so when we look at example 7, we need to know what tangent of A and tangent of B are. Well, if we're looking at tangent of A and tangent of B, the tangent of A is going to equal the sine of A over the cosine of A. Okay, so that is going to give us 3 over 5 over cosine of A is 4 over 5, which is equal to 3 over 5 times 5 over 4. These cancel out, so we get 3 over 4. So the tangent of A, I'm going to scroll down a little bit. The tangent of A is equal to 3 over 4. Let's find the tangent of B. The tangent of B is going to be the sine of B. I just get so excited. It's going to be the sine of B over the cosine of B, which is going to give us negative 12 over 13 over negative 5 over 13. which is negative 12 over 13, times 13 over 5, negative 13's cancel, so I get negative 12 over 5. Okay? And because they are both negative, it's a negative and a negative, so this is positive 12 over 5. So the tangent of B is 12 over 5. Now, my formulas. I know I'm scrolling back and forth on you guys. Let's keep it right here. We're going to find tangent of A plus B. Tangent A plus B is going to be equal to tangent of A plus tangent of B over 1 minus tangent A, tangent B. This is plug and chug right here, guys. Tangent of A, 3 over 4 plus 12 over 5 over 1 minus 3 over 4 times 12 over 5. Now that I have it rewritten, I'm going to scroll down, give myself some room. So we've got to add the numerators. Well, let's see. We need a common denominator. It's going to be 20. And so what I'm going to do is I'm going to multiply this one by 5 over 5 to get 20. I'm going to multiply this one by 4 over 4 to get 20. So that's going to give us 15 over 20 plus 48 over 20 over 1 minus, now this is going to be 36 over 20. So 1 minus 36 over 20 is going to give us a negative number, but on top we're going to have 63 over 20. And this is going to be equal to 1 minus 9 over 5. So that's going to be 63 over 20 over negative 4 over 5, which is going to be equal to 63 over 20 times negative 5 over 4. Let's see if anything cancels. It does. So I'm going to have negative, let's go up this way, negative 63 times 1 over 4 times 4, which is equal to negative 63 over 16. Not stuff we haven't done before, guys, as far as subtracting and using square roots and things like that. A lot of fraction operations here, guys. Got to keep them straight. Stay focused, and we'll see you next time.